Why does build orientation matter in 3D printing? Processes that use light to cure liquid resins, such as SLA, DLP, and PolyJet, produce isotropic parts, whereas processes that melt and solidify plastics, such as SLS and FDM, produce parts where strength in the X and Y axis is much stronger than the Z axis. This is because the interlayer bond strength is lower. If strength is critical for your part's performance, then it might need to be orientated to ensure the load paths aren't in the Z axis. The amount of finishing needed can be minimized by choosing the best build orientation for your part's geometry. Usually, the resolution in the X and Y axis is better, meaning a radius in the XY plane will have a smoother surface than a radius in the XZ or YZ plane. Each time new material is added, it affects the material it's bonding to. This causes residual stresses and results in distortion or delamination. Build orientation can help minimize or prevent distortion, depending on the technology used and your part's geometry. The more layers a part needs, the longer the build time. If time's tight, you might choose to orientate your part to minimize the Z-axis dimension. But build orientation also influences other parameters, like strength and surface finish. Unless speed's more important, we select an optimized orientation for part quality. We're always happy to talk about build orientation, or any other questions you may have. Please contact us to talk about your prototype project.